Welcome to Quiet Night Chronicles. Tonight, we embark on a peaceful journey across the northern seas, following in the wake of some of history's most remarkable navigators. Picture yourself standing on a weathered wooden deck, feeling the gentle roll of waves beneath your feet as we explore how Viking seafarers crossed vast ocean expanses without the guidance of magnetic compasses. These weren't tools of chance or luck, but sophisticated techniques honed over generations of maritime experience. Imagine the year is 870 AD, and you're watching a Norse longship prepare for departure from the rocky shores of Norway. The morning mist clings gently to the fjords, and the crew moves with quiet confidence as they ready their vessel for what might be weeks at sea. These mariners possessed an almost mystical understanding of the ocean's rhythms and the sky's subtle signals. Their navigational wisdom would carry them across the North Atlantic to establish settlements in Iceland by 874 AD, reach the icy shores of Greenland in 982 AD, and even touch the coastlines of North America around the year 1000 AD. What makes this achievement so extraordinary is that magnetic compasses wouldn't reach European waters until the 12th century, well after the golden age of Viking exploration had passed. So how did these seafaring people navigate across hundreds of miles of open ocean, often shrouded in fog and storms, with such remarkable accuracy? The answer lies in a fascinating combination of crystalline tools, wave-reading techniques, and celestial knowledge that reveals the sophisticated scientific understanding of these ancient mariners. Let us drift now to one of the most intriguing tools in the Viking navigators' collection, the mysterious sunstone. Picture a clear, crystalline fragment, no larger than your palm, smooth and transparent like captured ice. This wasn't ordinary glass or crystal, but a special mineral called Iceland spar, a form of calcite found abundantly in the volcanic landscapes of Iceland. When you hold this remarkable crystal up to the light, something magical happens. The world splits into two overlapping images, each slightly rotated from the other. This optical phenomenon, known as double refraction, occurs because Iceland spar has the unique ability to bend light rays in two different directions simultaneously. But for Viking navigators, this wasn't merely a curious natural wonder. It was a precision instrument that could reveal the sun's position even when thick clouds obscured the sky completely. The crystal acts as a natural polarizing filter, and when rotated slowly, while looking through it at the cloudy sky, there comes a moment when the two images suddenly match in brightness, pointing directly toward the hidden sun. Modern scientific experiments have demonstrated just how accurate this technique can be. Researchers have shown that Iceland spar can locate the sun's position to within 1 to 5 degrees of accuracy, even under completely overcast conditions. Imagine the confidence this gave Viking navigators as they sailed through the frequently cloudy and stormy North Atlantic. When fog rolled in or storm clouds gathered, they could still maintain their course with remarkable precision, guided by this crystalline compass that never failed to point toward their celestial beacon. The discovery of what appears to be a navigation crystal aboard an Elizabethan shipwreck in 2013 suggests that this ancient technique persisted well beyond the Viking Age, testament to its reliability and effectiveness. The crystal was found carefully stored in a wooden box near other navigation instruments, suggesting it held a place of honor among the ship's essential tools. Now let your mind drift to the gentle art of reading the ocean's own language, the subtle patterns and rhythms of waves that speak to those who know how to listen. Viking navigators developed an extraordinary sensitivity to the movement of their vessels, feeling through the hull's flexible construction every nuance of the sea's behavior. Their long ships, built with overlapping planks that allowed the vessel to flex with the waves, became extensions of the navigator's own senses. Picture yourself learning this ancient skill. If you close your eyes and feel the ship's motion, not just the obvious up and down of nearby waves, but the deeper, slower rhythms of ocean swells that have traveled hundreds of miles from distant storms. These swells maintain remarkably consistent directions, even when surface waves are chaotic with wind and weather. An experienced navigator could distinguish between the local wind waves created by immediate weather conditions and the deep ocean swells that had been traveling across vast distances for days or even weeks. The technique required extraordinary patience and sensitivity. Navigators would position themselves at specific points on their vessel where they could best feel these different wave systems. They learned to recognize the subtle differences in timing, direction, and intensity that revealed information about distant lands, weather patterns, and their position relative to known sailing routes. When fog descended and visibility dropped to mere yards, these wave patterns became highways across the ocean, as reliable as any marked road on land. This skill was so refined that navigators could detect the presence of land long before it became visible on the horizon. Islands and coastlines create distinctive interference patterns in ocean swells, causing waves to reflect, refract, and combine in characteristic ways. A skilled wave reader could sense these disturbances in the ocean's rhythm and know that land lay ahead, sometimes from distances of 20 miles or more. As darkness falls in our journey, we turn our attention skyward to explore how Viking navigators read the celestial map that arced overhead each night. The North Star, Polaris, held a position of supreme importance in their navigation toolkit. Unlike other stars that wheel across the sky throughout the night, Polaris remains nearly stationary, marking true north with unwavering reliability. Viking navigators knew that by measuring the height of Polaris above the horizon, they could determine their approximate latitude, how far north or south they had traveled. But the North Star was just one beacon in a vast celestial library that Viking navigators learned to read with remarkable precision. They studied the seasonal movements of constellations, noting how different star patterns appeared at different times of year and from different latitudes. The sun's daily path across the sky provided another crucial reference point, its height and direction changing predictably with both the time of day and the season. Imagine a navigator standing on deck during the brief summer nights of the northern latitudes, watching familiar star patterns emerge in the twilight. Each constellation told a story of direction and position, part of an oral tradition passed down through generations of seafaring families. These celestial maps were memorized with the same dedication that modern navigators might study charts, but they existed only in the minds of skilled practitioners. The sun's behavior provided equally valuable information during daylight hours. Viking navigators understood how the sun's path shifted throughout the year, appearing higher in the sky during summer months and lower during winter. They could estimate their latitude by observing the sun's maximum height at midday, comparing it to familiar reference points from their homeland or previous voyages. Deep in the heart of Viking maritime culture lay an extraordinary system of knowledge transmission that ensured these navigational secrets survived and flourished across generations. This wasn't knowledge that could be learned from books or scrolls. It was embodied wisdom that lived in the hands, eyes, and intuition of master navigators. Young sailors served long apprenticeships, spending years at sea, learning to feel the ocean's rhythms and read the sky's subtle signals. The relationship between master and apprentice navigator was one of profound trust and patience. Knowledge was shared gradually, often during the quiet hours of night watches, when the older navigator would point out subtle signs that the inexperienced eye might miss. They learned to recognize the distinctive color changes in water that indicated different depths or bottom compositions. They studied cloud formations, noting how different types of clouds formed over land versus open ocean, and how these aerial signposts could guide them toward distant shores. This oral tradition created a living library of maritime knowledge that was remarkably detailed and precise. Navigators memorized sailing directions between known points, including detailed information about distances, bearings, and distinctive landmarks. The Hagsbok manuscript from the 14th century preserves some of these sailing directions, offering us a glimpse into the systematic nature of Viking navigation knowledge. These weren't casual observations, but carefully recorded instructions that had been tested and refined through countless voyages. The social structure of Viking expeditions reflected the crucial importance of navigational expertise. Experienced navigators held positions of tremendous respect and authority, their knowledge literally determining the difference between successful voyages and disasters at sea. They guarded their most valuable techniques carefully, sharing them only with trusted apprentices who had proven their dedication and skill over many seasons of sailing. Let us pause now to consider the remarkable vessels that made these navigation techniques possible. The legendary Viking longships, whose very design enhanced their navigators' ability to read the sea. These weren't merely boats, but sophisticated instruments of exploration, crafted with extraordinary attention to how they would behave in different ocean conditions. Their shallow draft allowed them to navigate both open ocean and shallow coastal waters, while their flexible construction created a vessel that could literally communicate the sea's movements to its crew. The overlapping plank construction, known as clinker building, created hulls that could flex with the waves rather than fighting against them. This flexibility served multiple purposes. It made the ships more seaworthy in rough conditions, but it also turned the entire vessel into a sensitive instrument for detecting wave patterns. Navigators could feel through the ship's movement the subtle differences between different types of waves, distinguishing between local wind waves and the deeper ocean swells that carried information about distant conditions. The ship's relatively narrow beam and elongated shape made them particularly responsive to wave action, amplifying the signals that navigators needed to read. The placement of the steering oar at the rear of the vessel created a position where the helmsman could feel these movements most acutely, turning the act of steering into a continuous conversation with the ocean itself. Even the ship's minimal sail plan contributed to their effectiveness as navigation platforms. With a single large square sail, Viking vessels couldn't sail as close to the wind as later sailing ship designs. But this limitation forced navigators to develop exceptional skill in reading wind patterns and planning routes that worked with natural forces rather than fighting against them. Now let your thoughts drift toward the scientific principles that made these ancient navigation techniques so remarkably effective. The physics behind Iceland's spars, double refraction, involves the crystal's unique molecular structure, which causes light waves vibrating in different planes to travel at different speeds through the material. This creates the double image that Viking navigators learn to interpret. But more importantly, it reveals information about the polarization of skylight that remains consistent even when clouds block direct sunlight. The science of wave navigation draws on principles of oceanography that we're still studying today. Ocean swells are created by wind systems that may be hundreds or even thousands of miles away. And these waves maintain their direction and period with remarkable consistency as they travel across open water. Unlike surface waves created by local winds, these deep swells can provide information about distant weather patterns and, most importantly for navigation, maintain reliable directional references over vast distances. The consistency of these natural phenomena made them reliable enough to base navigation decisions upon. While individual waves might vary, the underlying patterns followed physical laws that Viking navigators could learn to recognize and predict. Their empirical understanding of these principles, developed through generations of careful observation, often matched or exceeded our modern theoretical knowledge of the same phenomena. Modern research into Viking navigation techniques has involved reconstructing their methods using period-appropriate tools and techniques. Experimental archaeologists have built replicas of Viking ships and attempted to recreate their voyages using only the navigation methods available to medieval Norse sailors. These experiments have demonstrated not only the effectiveness of these ancient techniques, but also the extraordinary skill required to use them successfully. Archaeological evidence continues to illuminate our understanding of Viking navigation practices, though much remains mysterious due to the oral nature of their knowledge transmission. Excavations of Viking settlements and shipwrecks occasionally yield navigation tools or references to navigation techniques, but the most sophisticated knowledge seems to have been passed from master to apprentice without leaving material traces. The discovery of what may be sunstones in later shipwrecks, such as the Elizabethan vessel mentioned earlier, suggests that some of these techniques continue to be used long after the Viking Age ended. This persistence across centuries testifies to their practical effectiveness, even as more modern navigation tools became available. Some of the most intriguing evidence comes from the settlement patterns of Viking exploration. The systematic progression from Norway to Iceland to Greenland to North America suggests navigation techniques that were not only effective, but also capable of improvement and refinement over time. Each new discovery built upon previous knowledge, indicating a sophisticated understanding of how to extend known techniques into unknown waters. As we near the end of our peaceful voyage across these ancient seas, let us reflect on the profound connection between Vikings and their maritime environment. Their navigation techniques represent far more than practical skills. They embodied a deep philosophical relationship with the natural world that modern seafarers might envy. These navigators didn't seek to conquer or control the ocean, but learned instead to listen to its rhythms and work in harmony with its patterns. This approach required tremendous patience and humility. A Viking navigator understood that the sea would teach those willing to listen, but it demanded respect and careful attention in return. Their techniques worked because they were based on careful observation of natural phenomena that had been tested and refined through countless voyages across some of the world's most challenging waters. The integration of multiple navigation methods, crystalline sunstones, wave reading, celestial observation, and traditional knowledge, created a robust system that could function even when individual techniques failed. If clouds obscured the stars, wave patterns remained available. When fog limited visibility, the sunstone could still reveal direction. This redundancy made Viking navigation remarkably reliable, despite the absence of mechanical instruments. Perhaps most remarkably, these techniques enabled some of the most significant voyages of exploration in human history. The Viking discovery of North America preceded Columbus by nearly 500 years, achieved using navigation methods that were entirely based on natural observation and human skill. Their settlement of Iceland created a thriving civilization in one of the world's most remote locations, while their Greenland colonies persisted for centuries in one of the planet's most challenging environments. Today, as we rely increasingly on electronic navigation systems and satellite guidance, there's something both humbling and inspiring about these ancient techniques. They remind us that human beings are capable of extraordinary achievements when we learn to observe carefully and work harmoniously with natural forces. The Vikings' navigational success wasn't based on overcoming nature through technology, but on understanding nature so deeply that they could become part of its patterns. As our gentle exploration draws to a close, imagine yourself standing once again on that weathered deck, but now with the wisdom of generations of Viking navigators flowing through your understanding. You feel the subtle communication between ship and sea. Notice the crystalline clarity of the sky above and sense the ancient rhythms that guided these remarkable voyagers across uncharted waters. Their legacy lives on not just in the lands they discovered, but in the timeless reminder that patient observation and humble cooperation with natural forces can achieve what might seem impossible. The navigation techniques represent a bridge between human ingenuity and natural wisdom, showing us that the most sophisticated tools are sometimes those that help us listen more carefully to the world around us. In our modern age of instant global communication and satellite navigation, these ancient methods offer a peaceful reminder of the profound knowledge that can emerge when we take time to observe, learn, and move in harmony with the rhythms of the natural world. If you found this journey across ancient seas peaceful and enlightening, consider subscribing to Quiet Night Chronicles for more restful explorations of history's hidden wisdom. Until next time, may your own voyages be guided by patient observation and gentle wisdom. Sleep well.